Okay, I'll start. Okay, write down these two questions which I have written. How does you should write, how does a latitude of a place affects insulation? Somebody is unmuted. Who is this?
Sir, this was Dipankar.
Okay. So why does, and the second question is, why does tropical zones receives more insulation as compared to frigid zones? Have you written both the questions, all of you?
Yes,
So
sir.
can you repeat question number 1?
How does a latitude of a place affects insulation? Okay, shall I erase it?
Yes, sir.
So please wait for a minute.
Please be very quick. Okay, shall I do it now? Now we're going to talk about atmospheric pressure now. Okay, and we have a diagram here. Before that, I think we have already discussed this phenomena. Okay, if you've seen that these are the areas where the direct rays of the sun, whereas these are the areas where there are indirect rays of the sun. Yeah. Do you agree all? I think we have already discussed this.
Yes,
Now
sir.
coming
Yes,
to
yes, sir.
atmospheric pressure. Atmospheric
Your
pressure.
voice is not.
Is it for everyone? My voice is jarring.
No,
No,
sir.
sir.
No, sir.
It is
It
clear.
is coming. Sir,
Okay.
clear.
Okay. Ishvi Omar, your video. Ishvi Omar, your video. Akarshi, sit properly. Raghav Dubey, Zaid Ansari, your video. Zaid Ansari. Just a second, children. Let me. Okay. Nithani, write down few names.
Yes, sir.
Hardik. Then Tushar. Hardik, Tushar, Shavez, Oves. Hardik, Tushar, Shavez, Oves.
Yes, sir.
Then Zaid, Manya. Zaid, Manya. They will be
Yes.
marked absent because on my repeated reminders, they don't listen and they keep their videos off. Manya particularly, she's doing it. Whenever I check her, she keeps it on. And whenever I uncheck her, she again switches off the video. Okay, Krishna, thank you.
Yes.
So, now what is atmospheric pressure? So it says that the force exerted, it is the force exerted by the vertical column of air per unit area. See, we all know it's air all around. Now this air is actually putting up lots of pressure. It is putting up lots of force towards the ground. So this is actually known as atmospheric pressure. So even if you go through the resource sheet or if you go through the book, the force exerted by the vertical column of the air per unit area is known as atmospheric pressure. So the first question automatically becomes, what is atmospheric pressure? Was it there in the learning terms? Yeah, it was there in the learning terms. So you need not to write it. The atmosphere surrounding the earth is held to it by gravity. Please underline this. Therefore, the air has weight and exerts force on the earth. Although air has very little weight, yet due to its great height of several hundred kilometers, the column of the air above the surface exerts considerable pressure. Is it clear?
Yes, sir.
So where we have 2 marks?
But it is given on page number 30, atmospheric pressure, second paragraph. Now we're going to talk about two important factors that actually affect the atmospheric pressure. The two important factors which actually affect the atmospheric pressure are number one, altitude, and number two, what is number two? Temperature.
Temperature.
Okay. Now see, altitude, what happens with altitude? If altitude goes down, atmospheric pressure goes up. And if temperature goes down, atmospheric pressure goes up. It's just the opposite. So you can say high temperature, okay, high temperature, less atmospheric pressure. Okay, ATM means atmospheric pressure. Similarly, high altitude, less ATM, that is atmospheric pressure. So it is just inversely proportional. So inversely proportional means if one quantity increases, the other quantity decreases. So it says that pressure decreases with height. Atmospheric pressure at the highest is highest at the sea level because air is densest at the sea level. As we climb up, the air starts thinning. So we all know, see, troposphere is the densest layer. Raghav Dubey, sit properly. We all know troposphere is the densest layer. Okay. So as we go up, as we go to more and more height, the altitude increases, the atmospheric pressure will decrease because the air starts thinning. The density of the air reduces. Okay. Is that clear? You can understand this?
Yes, sir.
Density of air reduces. Okay. And let's talk about temperature. Pressures decreases with increase in temperature. When temperature rises, air expands and molecules move further apart, and hence lower the pressure. See what happens. If this is, suppose if this is air, okay, these are air molecules. Now, when this thing gets heated, when it gets heated, what happens? The air expands, the molecules goes far apart. So in which condition the pressure will be more? This one, the first situation, or in second situation? In which situation the atmospheric pressure will be more?
And in the first.
Sir, in the first one.
In the first one, because the molecules are closer to each other and therefore they will apply more pressure. And in the second situation, the molecules are far apart. Therefore, and why are they far apart? Because they have gained
expanded because of it.
because they have expanded, right? Is it clear, children? So this is how temperature and altitude affects the atmospheric pressure. So now you should write down some questions. First question you write down, name and explain the two factors that affect atmospheric pressure. name and explain that affect, name and explain two factors, sorry. Name and explain that affect atmospheric pressure. You should write complete. I have left space, so I have written ATM. Okay. The two factors are altitude, and you're going to write down these points only, which are there in your altitude, which are there in your resource sheet.
Sir, what you have written after effects?
Atmospheric pressure.
Affects atmospheric pressure. Nithani, write down Akarshi Jain also.
Okay, sir.
Ananya, where have you gone? No, Ananya is lost.
Sir, Ananya has connectivity issue in every period.
But in my period, she's having. Priyanshi, see what your sister doing. She's so small, huh? And she looks so smart in the school uniform. See, school uniform, it's very, very important to wear, children, you know. It gives you a grace. It makes you alert. It makes you smart. Look at that small child. She's looking so smart. See, it's happened. Uniform has always been something that adds grace to your personality. Okay. Have you written this? Then we're going to talk about the world's pressure belts. Right? The next topic is world's pressure belt. So write down a few questions before I proceed. The first one is name the major pressure belts of the world. Name the major pressure belts of the world. Name the major pressure belts of the world. Okay. So there are 4 major pressure belts, if you can see, children. It is equatorial low pressure belt, that is also known as doldrum belt, subtropical high pressure belt, subpolar low pressure belt, and polar high pressure. Is that clear? So what is the cause of these pressure belts? See, world pressure belts, how are these pressure belts found? They are found because of the difference in the atmospheric pressure. Okay, now why does atmospheric pressure variate? Why is atmospheric pressure not same in all places of the earth? What should be the answer? I just write down this question, and you all should also write down this. Why is pressure, or I should write not same at all places of the earth? Now, who's going to answer this question?
Sir, can I answer?
Yeah, Nithani, bolo. What should be the answer?
Sir, because every place has its own altitude and temperature, and it varies from place to place.
Altitude thing is not acceptable, but because of the temperature. See, in the previous class, we read that not all the places of the earth receives equal amount of heat. Do you all agree? Even if you see
Yes.
this diagram, in this diagram some places which receives that slanting rays of the sun. And because they're receiving slanting rays of the sun, so this area and this area will have less temperature. And if the temperature is less in these areas, pressure will be
Sir, less.
Sir, more.
More. It's inversely
Sir,
proportional. As I told
Sir,
you,
more.
it's inversely proportional. Just ulta hota hai. If the temperature is less, pressure will be more. If the temperature is more, pressure will be less. And this is the reason, if you see this, if this is the earth, I'm sorry, it's looking like something else. I'm really sorry, I'm very bad at drawing. So please bear me for this period. अब जैसा बन गया है, please, okay? Don't make fun of me. Okay, so this is Arctic Circle. This is Antarctic Circle. This is Tropic of Capricorn. Sorry, Tropic of Cancer. This is Tropic of Capricorn, and this is Equator. Right? Now, this region. What is the first equatorial low pressure belt? If it is equatorial low, if it is low, the temperature is
High.
Sir, high.
High.
exactly. The temperature is high. Then again we move here. This becomes subtropical. So this area is tropical. ये itna area is tropical. This area is
Subtropical.
subtropical. It again becomes high.
High.
And then
High.
it again goes up. It becomes subtropical high. Okay. Then again subpolar, just below the polar regions, it again becomes low because the temperature increases. And then moving up towards the polar regions, it becomes high pressure. So polar high, subpolar low, subtropical high, equatorial low. Now, why is this thing happening? आप बोलोगे सर पहले बहुत ज्यादा है, फिर कम है, फिर ज्यादा है, फिर कम है. ये वेरिएशन क्यों है? Why so much change? The answer for this is quite easy. And the answer is unequal heating of the Earth's surface. So here, if you see in the notes, unequal heating of the Earth's surface and its atmosphere, rotation of the Earth leads to the formation of pressure belts. So unequal heating.
The causes
unequal heating of Earth's surface and atmosphere. Right? And rotation. What is rotation? Spinning of Earth on its own axis. Is that clear? Now what happens? You do one thing, all of you. If you have a ball, you take a Costco ball. If you have a Costco ball, because it has some fabric in it, you dip it in water and rotate it. You will find when you rotate the Costco ball, it will throw out water in different directions. Even if you take a normal ball, you dip it in water and you turn it with a great speed, you will find it is dripping water. Now that is known as centrifugal force. What is it known as?
Centrifugal.
I'm just telling you for the sake of information. The centrifugal force. So rotation से क्या होता है? Develops centrifugal force. And this also leads to the deflection in the winds. So जो winds होती हैं, वो भी deflect हो जाती हैं इससे. So that is also one reason. Okay. Now, the regions with high temperature have low pressure belts and vice versa. So the areas which have high temperatures, they will have low pressure belts, and the areas have low temperature will have high pressure belts.
High.
Is it clear? And how does wind blow? How does a wind blow?
With high pressure.
High pressure to low pressure. This is the direction of the blow of the. Is it clear, children? So
Yes,
there are
sir.
4 types of,
Yes, sir.
we have written this. So why atmospheric pressure not same at all places? Can you write down one more question? What are the factors for the formation? What are the factors for the formation of pressure belts in the world? Is it clear?
Yes.
Yeah.
Yes, sir.
So let's move to the next part. The next part is humidity. Let's quickly finish it. Humidity, we have very less time. So humidity, amount of water vapor present in the air. We have discussed it in the first slide. When we were talking about the elements of the weather. So there are 2 types of humidity. One is absolute and the other one is relative. When I say absolute, that means we are talking about only one particular thing. कि air में कितना vapor hai. That means amount of water vapor in the air. We are not comparing it with anything. So that means absolute. Absolute means when we are not comparing it with any other quantity. So it says that, please, this is very, very important. Amount of water vapor, please see the short sheet. Amount of water vapor in grams per cubic meter of air. Please, this is the key word. Grams per cubic meter of air. And what is relative? Now, it is ratio between the amount of water vapor present in the air and the amount that can be held by the air at a given temperature. It is expressed as percentage. Okay. How much water vapor is there in the air and how much water vapor a air can hold at a given temperature. Kitna hai or kitna ho sakta hai. Are you understanding that? So that is relative because here we are relating and it is in the form of ratio. It is calculated as percentage. I'm telling you again, I think few of you are confused. Relative means the amount of water vapor present in the air to the amount of water vapor a air can hold at a given temperature. At a given temperature, see this, at a given temperature, this is a keyword. Okay, and it is expressed as percentage. Okay? Is that clear? It is expressed as percentage. Is this clear, children? Have you understood the difference? So the first question, the first question becomes, what is the difference between absolute and relative humidity? Is that clear? Absolute and relative humidity. Is that clear, children? Am I clear?
Yes, sir.
Okay. Now, key terms, saturated air and unsaturated air. Up saturated air and unsaturated air. Let me tell you, you take a glass of water. Okay? Just a simple example. Or in other terms, we can do one thing. I'm not having cotton right now. You take a cotton, right? You do it after the class, and you pour water on that cotton, dip by dip. Okay? Drop by drop. You will drop when you will drop first, it will absorb. You will drop second, the cotton will absorb the water. Again, you drop. When you keep on dropping water in that cotton, one stage will come when the water from the cotton will also start dripping. Why it happens?
Sir, because that
Because the
because of
capacity of the cotton is only that much water.
Yes, sir.
Actually,
Because the capacity of the cotton is over, that's why.
yeah, when the capacity is over, that is known as saturation. What does it known as? Saturation.
sir, saturation.
हम ये बोलते हैं, we say it that now that cotton has attained a age of or a state of saturation. Now that cotton cannot hold more water. If we pour more water on that cotton, what will happen? The water will start dripping
It
from
will
the
start
cotton.
dripping.
The same is the case with the glass. A glass has some some capacity to hold water, and if you keep pouring water on it, the water will start overflowing. We say that the saturation level of glass is over. And unsaturated means it can still hold it. It can still hold it. It is not full. It is still hold it. So it says that key terms are saturated and unsaturated when the relative humidity of air is 100%. Okay, relative humidity of 100% means अब इससे ज़्यादा water vapor air में नहीं आ सकता. It is called saturated air. And when it is less than 100%, it is called unsaturated air. So saturation means अब इससे ज़्यादा नहीं हो सकता. 100% saturation means अब air इससे ज़्यादा water vapor absorb नहीं कर सकता. Right? It cannot hold water vapor more than 100%. And if it is less than 100%, we call it as unsaturated air. Is this clear, children? Is this clear?
Yes, sir. Yes, sir.
Then we have precipitation. Now, what is precipitation? Deposition of water from atmosphere to the surface in any form. By atmosphere, we have water vapor, right? Now, this water can come to earth in any form. It can come in the form of rain. It can come in the form of hailstorm. It can come in the form of snow. It can come in the form of dew also. So, it says that precipitation has 4. The first one is rain. We all are witnessing rain. Dew is witnessed in the winter seasons when we wake up in the morning and we say, "Dekho, os padi hui hai, osi os hai." That is known as dew. And hail, which is actually frozen lumps of ice. I hope you all have seen ice falling from the sky. And snow is a powdered form of ice. Okay. So rain reaches in liquid form. Dew, they are the drops of water formed when the moist air comes in contact with the cold surface. So in the winters, what happens? Everything becomes cold, and the water vapor comes in contact. If the water vapor comes in contact with the cold surface, it actually freezes on it. It condenses on it, right? Then hail, frozen lumps of ice, and snow common in higher latitude areas. Like higher latitude, it should be higher altitude. इसको edit कर लेना, altitude. Higher altitude areas like mountain regions composed of ice crystals. Is that clear? So I'll keep it till here. You can write down one question. Explain. नहीं, सबसे पहले what is precipitation? Then explain the 4 types of precipitation. Is that clear? Explain the 4 types of precipitation. Yes, children? Is this clear?
Yes, sir. Sir, the period is over.
I know. Just 1 minute. Just 1 minute. I know.
Yes, sir. Yes, sir.
Okay. So I hope till here I'll be uploading these 2 videos on the YouTube also, so that you can just have a quick revision of everything. Okay. So have you understood this thing, children?
Yes, sir.
Yes, sir.
So
Yes, sir.
I end my class today from here. Next class will begin with thunderstorm. We are left with thunderstorm thing. Then we are left with winds, clouds, and weather instruments. Okay, that will do it quickly. Okay. So That's all for today. Thank you very much. It has been I hope you were not feeling bored, children.